Hello everyone. In today's lesson, we'll be moving over to prime numbers. Now, what are prime numbers? Prime numbers are numbers that can only be divided by itself and 1. And you'll be wondering, what number can be divided by itself and 1? In our last class, we had an exercise which we had to find the common factor. One of the exercises, we were given 5. Now in 5, we found out that if you were to divide 5, you could only divide 5 by 1 and 5 divided by 5. These were the two things you can use to divide 5 to get whole numbers. Any other thing you use to divide 5 will give you a decimal point, and that is a remainder. That shows that if we were to get the prime, to get 5 is a type of prime number, or is a prime number, as 1 and 5. There is no other number that can divide 5 without a remainder. There are other prime numbers. For example, we have 2. We have types of prime numbers or examples of prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and the list goes on and on and on. Now, I have defined prime numbers as numbers that can only be divided by itself and 1. That is to show 2 can only be divided by 2 divided by 1, or 2 divided by 2 to give us whole number as this answer. Any other thing dividing that wants to divide 2 will give us a remainder, which, for example, if I'm to say 2 divided by 4, from here we have what? It's equals to what? 1 over 2. That's just to show you that we still remember the remainder of what? That extra 2. So in order to get whole numbers, not to have whole numbers, the prime numbers can only be divided by 1 and itself. Under prime numbers, we have what we call prime factor. Now, what's a prime factor? A prime factor, these are factors which are prime numbers. You might be wondering, what do they mean by this now? Let's say, for example, when I said 6, what are the factors of 6? And I was like, mention all the common factors you have. That's 1, that's 2, that's 3, that's 6. These are all the common factors. These are common factors of 6. You'll be wondering, now where is the prime factor? A prime factor, as I've said before, are factors which are prime numbers. From here we can see 1 is a prime number, 2 is a prime number, 3 is a prime number, but 6 is not a prime number. You understand? Because 6 now you can do 6 will be equal to 2 times 3. Though they are prime numbers, but that's what you get when you do 6. So which means that the prime factors from 6 will be what? 1, 2, and 3. When you understand it this way, you won't get much more confused. When anyone is to ask you, tell me the prime factor of so, or tell me what the prime factor of this. If they are to give you 24 and tell me the prime factor of, all you have to do first of all is bring out the common factors of 24. When you bring out all the common factors of 24 down, the next thing you do, you now go back to your common factors, little by little, all the factors there. You divide them, you check. In all the factors, 1, we all know that if you do 1 will be divided by itself. There's no other number that can divide 1 and not be a decimal, not give you decimal point. So 1, a prime factor. We have 2, a prime factor. You move on. You have 3. 4 cannot be a prime. But we have 4. We have 6. And 6 cannot be a prime factor. We have 8. 8 cannot be a prime factor. And I think that's all. I think this is all you get. These are all the prime factors for 24. 1, 2, and 3. And that's how you could keep on doing it for others. Keep on doing it for others. You do know 23. 23 is a prime factor. There are much prime factors. You can do from 1 to 100. You can do as an exercise from 1 to 100. Find the prime numbers there. This will help you to broaden your knowledge of prime numbers. You can just do 1 to 100, find the prime numbers, and then you check them out. For 23 now, you can do, if you do 23 divided by 2, it's going to give you a remainder, because 2 will only go into 22, not 23. But if you are to do by 23, you get a whole number. If you are to do 23 divided by 1, you get 23. Any other number you're to use to divide 23 is going to leave you with the remainder. And that is not a factor. And that cannot even be Topmuffin prime number. And with this, we have come to the end of prime numbers. If you have any question for me, don't hesitate. Ask your questions below. I'll get back to everyone, answering each and everyone's question. We are here to understand our basis, to understand our foundation of mathematics, to make mathematics look very simple. If there's anywhere you are confused, anywhere I lost you, please come, ask your questions, bring my attention back to that. I'm free to answer your questions. There are many other prime numbers. Do not limit yourself to here. I said 1 to 100. You can make 1 to 1000. There are many prime numbers that it's only one and itself that can divide it. Any other one will give you a decimal point, which is a remainder, or will be a fraction. Yes, there are some people that when they divide this, they won't divide it in a way that it will be point. They'll divide it in a way that something will remain under, something will remain there. Let me see. For example, when I was dividing 2 divided by 4, I said 1 over 2. That's a fraction. Someone can come up here and be like 0.5 and tell you 2 divided by 4 is equal to 0.5. So one can even go as far as using long division, be like 4 and 2, and you'll be like, what? How? Now, I think maybe I'll take you on long division as a bonus. Let's go for long division.